Welcome all. In last lecture we have seen what is Kmap, Kmap structures for 2 variable, 3 variable and 4 variables. After that we have seen the product terms related to the Kmap cells and Kmap in the form of mean terms. Today we will see the next part, that is representation of truth table on the Kmap. Inside the boxes of Kmap we have to enter the values of outputs corresponding to different combinations of inputs. In this slide it is shown the relation between a truth table and Kmap entries for two variables. This is the truth table in which there are two inputs and one output, and this is the Kmap. Now we have to enter the output values in the four boxes of the Kmap with their respective input combinations. If we observe this first output, that is 0, it is related to the input combinations 0 0, that is A and B values. Now this is 0 0, so I can write it as A bar B bar. So I have to enter its corresponding output in the cell where the product term will be A bar B bar. So in this position I will get the product term A bar B bar. Therefore this 0 is written in the first cell. After that the second output is also 0, for which the product term will be, here the values of A and B are 0 1, that is A bar B. So the product term A bar B will appear over here, that is this is the position for 0 and 1. So this 0 is entered over here. After that the next input combination is 1 0, that is the value for A and B are 1 0, that is A B bar. So the position of cell is this one, so here the value is 1 and here it is 0. So this third 0 can be entered into this cell where the product term is AB bar. After that next input combination is 1 1, A1 and B1, that is the product term will be AB and the position of that AB product term is over here, for which the value of A is 1, value of B is also 1. So this last one will go at this cell position. This is the one way to enter the values of outputs into the Kmap cells or boxes of the Kmap. Here vertical variable is A and horizontal variable is B. This is the alternative way to write the output values into the Kmap, where the vertical values are written for B and horizontal values are written for A. Next we will see the representation of truth table onto the Kmap for 3 variable inputs. This is the truth table for 3 variables and we have to enter the values of these output into the Kmap. Here all the 3 possible formats of Kmap have been shown, in which the respective output values for various combinations of inputs entered into the Kmap cells. So I will tell the entries of output values into this Kmap. So here vertical variable is A and horizontal variables are BC. Now first value of output is 1, for which values of A, B, C are 0, 0, 0. That is, the product term will be A bar, B bar, C bar, and the position of product term A bar, B bar, C bar is this first cell. So this one is entered over here. Similarly, we can see the entry of this output value for which input combinations are 0, 0, 1. 0, 0, 1 position is come in this cell, so I can enter the next 0 over here. In the same way, for third output, that is 0, the input combination is 0, 1, 0. So 0, 1, 0 position is over here, so I can enter the 0 into this cell. Again, next combination of input is 0, 1, 1. So the position of 0, 1, 1 is over here, therefore fourth one is entered into this cell. Similarly, we can enter the remaining 4 entries into the remaining cells of the Kmap. This is how we can enter the output values for the corresponding different combinations of inputs or for their respective product terms. This is another way to represent the Kmap, where the C is the where variable C is taken vertically and AB variables are taken horizontally. And in the third format of this Kmap, where BC variables are taken vertically and A variable is taken horizontally. Next, we will see the representation of truth table on the Kmap for the 4 variables. Again, this is the truth table for 4 variables, and these are the 2 possible combinations of Kmap for the 4 variables. So I will tell for this Kmap how the entries are made for the output values with respect to the various input combinations. Now I will enter this value 1, for which position of ABCD are 0, 0, 0, 0. This is 0, 0 and this is 0, 0, and the position is over here, so I can enter 1 into this cell. Similarly, if I take this output 1, for which the input combination is 0, 0, 1, 1, so the position will come over here, for which AB is 0, 0 and CD is 1, 1. So I can enter next one in this cell. If I observe the input combination for this one, that is 0, 1, 1, 1. So here it is 0, 1 and 1, 1 means the cell comes over here. So I can enter this one in this cell position. After that, next one is having input combination 1, 0, 0, 0. So the position will come over here 1, 0 and this 0, 0. So the cell position will be over here. So that one is entered in this. After that, if I observe the next one, for which the input combination is 1, 0, 1, 1. So this is 1, 0 and 1, 1 is over here. So the cell position comes here. So that one value is entered in this cell. And if I observe for last one, the input combination is 1, 1 and this 1, 1. So the cell position comes over here. So the output value 1 is entered in this respective cell or box. For the remaining input combination, the output is 0, so directly we can enter zeros in the remaining cells. This is a shortcut to enter the output values, in which we can observe only the input combinations for which the output is 1. After that we can enter the zeros for the remaining cells. This is the another way to represent the output values into the Kmap, where CD variable taken vertically and AB variables taken horizontally. So as the position of CD and AB is changed, the entries of output values also get changed as their position gets changed. Now we will see representation of standard SOP form onto the Kmap, how we can represent the given expression into the Kmap. For that we have to enter the ones in the cells or boxes of Kmap corresponding to each mean term, that is for each product term, and we have to enter the 0 for the remaining positions of the cells. Now in this equation there are 5 product terms, so I can enter 5 ones in the boxes of the Kmaps. So first product term is A bar, B bar, C bar. So the position of A bar, B bar, C bar product term is over here, so 1 is entered in this cell. Second product term is A bar, B bar, C. So the position of that A bar, B bar, C is, this is A bar and this is B bar, C. So the position comes over here, therefore 1 is entered for that respective position. Next product term is A B bar, C bar. So A B bar, C bar position comes, A B bar, C bar, A B bar, C bar. So the next cell position is over here, therefore 1 is written in this cell. After that next product term is A B bar, C, A B C bar. So the position of cell is, here is A and here is B C bar. So A B C bar, this is the cell position where 1 is entered. After that next product term is A B C. This is A and this is B C. So 1 is entered in this cell. This is how we can enter the ones in the cells for the each corresponding mean term or product term, and for the remaining cells we can enter simply zeros directly to complete the entire entries of all the boxes of the Kmap. In this all the product terms are mentioned for each ones which we have entered over here. Okay. Now we will see the representation of standard SOP form on the Kmap for the next Boolean expression, which contains 4 variables. In this the Boolean expression contains 3 variables, so we have used 3 variable Kmap. Now as this expression contains 4 variables in each product term, so we have to use the 4 variable Kmap. Here there are 4 product terms, 1 2 3 4, for which we are going to enter 1 in each cells. So first product term is A bar, B bar, C bar, D bar. So I have to find out first the position of the cell for the said product terms. So A bar, B bar, C bar, D bar position is over here, so I have to enter 1 in that place. Next product term is A bar, B bar, C D. This is A bar, B bar, this is C D. So the cell position is over here, therefore 1 is entered. Next product term is A bar, B, C D bar. A bar B means this row and CD bar means this column. So the cell position comes over here, therefore 1 is entered in that place. Next product term is AB, this is AB, and C bar D bar, this is C bar D bar. So the cell position comes over here, therefore 1 is entered in this respective cell, and for remaining cells or boxes a 0 is entered directly. This is how we can enter the values of outputs for each product term in the given expressions as 1, and we can enter zeros for the all remaining input combinations or all the remaining product terms. Now next is the Kmap reduction techniques for the Boolean expressions. So the simplification of Boolean expression using Kmap is based on combining or grouping the terms in the adjacent cells of a Kmap. So before going to the Kmap reduction techniques, we have to understand the concept of adjacent cells. So if two cells of Kmap are said to be adjacent if they differ in only one variable as shown below. In this, a 3 variable Kmap is shown. So here the cells are numbered as 1, 2, 3, 4, 5, 6, 7, 8. Now in this I can say the cells 1 and 2 are adjacent with each other. In this I can say the cells 1 and 5 are adjacent with each other. But I cannot say the cell 1 and 6 are adjacent with each other, and also I cannot say the cells 2 and 5 are adjacent with each other. So this is how we can we have to find out the adjacent cells like this. Now in this I can say the 1 and 4 are adjacent with each other as the only one variable is changing, that is A is changing over here. Here A is 0, B is 0, and here B is 1. C is same for the both the cells, that is 0 0. Therefore I can say this 1 and 4 are adjacent with each other. Similarly I can say the 5 and 8 are adjacent with each other as again the only one variable is changing, that is B variable is changing from 0 to 1, and C variable remains same as it is as 0 to 0. This is how we have to find out the adjacent cells. Similarly here again the adjacent cells are shown. In this, as I have said earlier, these two cells are adjacent with each other. These two cells are adjacent with each other for 3 variable Kmap. This is the 4 variable Kmap for which these two cells are adjacent with each other. These two cells are adjacent with each other. All these 4 cells are adjacent with each other, or I can say that these two cells or this one and this one is adjacent with each other. This cell and these cells are adjacent with each other. Similarly in this I can say that these two cells are adjacent with each other. These two are adjacent with each other. These two are adjacent with each other, and these two are adjacent with each other. In all I can say that these 4 cells are adjacent with these 4 cells. This is how we have to identify and observe the adjacent cells in a given Kmap, by which we can group or we can apply the Kmap reduction techniques to minimize the given equation. In all there are 3 ways of grouping in which we are going to group the ones for SOP expression or zeros for POS expression to reduce the given equation. The first one is pair method, in which a group of 2 adjacent ones for SOP expression, or a group of two adjacent zeros for POS expression is to be formed, which is called as a pair. In the chord method, we can group the four adjacent ones for SOP expression, or we can group four adjacent zeros for POS expression. Here it is written as by mistake pair. Actually here we have to write a chord. So in chord method we have to group four ones together which are adjacent with each other. In octet method, a group of 8 adjacent ones for SOP expression, or a group of 8 adjacent zeros we have to form, which is nothing but called as a octet. So this is how we can group 2 ones for pair, 4 ones for chord, 8 ones for octet method. The remaining detailed techniques of pair method, chord method and octet method we will see in the next lecture. Thank you.